Okay.
Fast one or a long one?
It can be either quick or it can be long. It depends on how quick we understand the material. That's the truth of it. Certainly, expressing rational numbers as decimals should be something that you've done before. In other words, changing a fraction into a decimal just requires us to be able to divide. This is a section where we should be able to do all the work without a calculator. Okay? Shouldn't need a calculator to do this. I think the difficulty comes in this section not from the rational numbers, but comes from the irrational numbers. A rational number is any number that can be represented as a fraction or a ratio of two numbers. If the decimal terminates, it's rational. If the decimal repeats, it's rational. We can represent it as a fraction. We're going to learn how to do that part today. Take a repeating decimal and represent it as a fraction. Some of them you already know, like 0.333 repeating should be something you know. What is it? 1/3. So if I can change that one, there must be a way to change any of them into a fraction so I can see what the actual value is. And we're going to talk about that today. The problem comes with dealing with irrational numbers. What's the most common irrational numbers? Anybody know? Pi. Because not only does it not terminate, it never repeats itself. The other things then that become irrational are square roots. The square root of 4 is rational. Why? What is the square root of 4? 2. So it's a rational number. But the square root of 3 is irrational. Although your calculator may stop, that number itself would never repeat, never have an end. The square root of 2, also irrational. So if it's not a perfect square, in other words, I can find the square root of it, then if it's got a square root symbol in it, it's going to be an irrational number. And we're going to talk about how to find the value of that without using a calculator. That becomes the trick. How do you find it? There's a square root button, yes. I understand there is. But not every day is this right at your access. And you should be able to tell me roughly what the square root of 2 is.
Is it true that, I'm pretty sure it is, isn't it true that 2 is the only even prime number?
Yes, 2 is the only even prime number. Because every other even number is also divisible by 2. So 2 is the only even prime number. To be prime, it can only be divisible by 1 and itself. Okay? So, we've talked about what this concept of rational is. We certainly should know what a terminating decimal is. In other words, it has an end, it terminates. A repeating decimal is any time you see one number or a block of numbers that repeats, like 0.15, 15, 15. Okay? So the first thing we're going to do is talk about the year terms. Should be on the next page. We're going to convert both of these fractions and or mixed numbers to a decimal. This part should go easy. We should already know how to do this. After all, what is a fraction? What's a different word for a fraction? What is it? It is a what? Somebody said it? It's a division problem. That's realistically all that it is. So, when I'm looking at this number 2, it's saying I'm taking 1 and dividing it by 8. The 8 goes on the inside, the outside. The 1 is on the inside, and I put a decimal down. Does 8 go into 1? No. I add a 0. Does 8 go into 10? Yes. Goes into it once. I multiply, subtract, bring down another 0. 8 go into 20. Twice. 2 times 8? 16. I subtract, bring down another 0, and this becomes a 5. 0.125. If you put 0.125, there's certainly nothing wrong with not having that lead 0 there. Doesn't matter. So everybody remember changing fractions into decimals. Okay. When you're changing a mixed number into a decimal, I personally don't do anything with the 2. I leave it alone. Some people like to change their mixed number into an improper fraction and then do the division. Either method works. All I'm really interested in is this fraction part. And we already said what 1/3 was going to be. Did 3 go into 1? No. Does 3 go into 10? How many times? And when I multiply it out, I'm bringing down a 1, and it's going to have the same number, right? So this is 0.33333 repeating, which is written as 0.3 with a bar over the top of it. What do I want to put in front of my decimal now? The 2. Everybody remember doing this? This part should all be a review. Everybody good? I can go on then. Okay. Now we're going to talk about how to go the other direction. If they give you a decimal, how do we write it as a fraction and how do we simplify it? Well, number 4 should be easy. You should know how to do this one. Because each place behind a decimal has a name. What's the first place behind a decimal? What column is that? Tenths. What place is the second place? Hundredths. So this becomes 12 hundredths, or 12 over 100, as a fraction. Okay? Now, I can simplify this. What will go into both 12 and into 100? 4. And I'm going to divide both the numerator and the denominator by the same thing. 4 goes into 12 3 times. 4 goes into 100 25 times. So in simplest form, we get 3 over 25. This, too, should also be a review. You should remember how to do this. This one you may have not done before. Has anybody changed a repeating decimal into a fraction? You have? What do you think this would be?
I don't remember because I haven't done it so long, but I have done it before.
Okay. What's important to recognize is when you're talking about 0.57 repeating, that it literally would keep on going like this, right? If you see 2 numbers that are repeating, I'm going to let this be a variable. I'm going to let this be x. If there's 2 numbers that are repeating, in other words, it's repeating over to the hundredths place, then I want to multiply this x by 100. If I multiply x by 100, what would I have to do on the other side to make the equation the same? Multiply by 100. When I multiply by 100, it moves the decimal 2 places. If I move it 2 places, it becomes 57.575757 forever. Right? Everybody with me that far? Understand what I've done? The rest of it's easy. We're going to subtract. What's 100x minus x? 100x, take away 1x. 99x. If there was 100 x's and I took 1 x out of the group, there'd be 99 x's left, correct? What happens when I take 57.575757 forever and I subtract 0.575757 forever? What does it become?
57?
It becomes 57. Everything behind the decimal goes away. That's the reason I multiplied it by 100, is so the part that's behind the decimal would look exactly the same. How would I find the value of x? Divide by 99. Lo and behold, x is now 57 over 99. And if you'd like to check the math, take 57 and divide it by 99 on your calculator and see what it gives you.
6.3 repeated. I got 57.57.
It should be 0.575757, and it might round the last number up to 8, but that's because that calculator doesn't keep track of that. Everybody with me? Understand how to do that one? Do we need to do another one like that so you feel better? Okay. So this time I'm going to do one that we should already know. Okay? I'm going to do 0.3 repeating. Because we already know that should be what? 1/3. We already know this. Okay? Well, if it's 0.3 repeating, it would be 0.3333 forever. And what am I going to let that equal? X. How many places we're repeating this time? 1, just that tenths. So instead of multiplying by 100 this time, what am I going to multiply by? By 10. If I multiply the x by 10, what do I got to do to the 0.3333? Multiply it by 10. So it becomes 3.333 repeating. Right? What do I do with these numbers now? I subtract. What's 10x take away 1x? 9x. What's going to happen to everything behind the decimal? It's going to go away and leave me just 3. What am I going to do? I'm going to divide both sides by 9. If it's 3/9, that's the same as 1/3. I looked at this number and said it's only repeating to the 10th column. So I multiplied by 10. In this one, it was repeating 2 places, the hundreds, right? So I multiplied by 100. If there was 3 places repeating, what would I multiply by? 1,000. Okay? Everybody understand the concept? We good? Okay. Now we're going to talk about the idea of this square root. And there's certainly some misconceptions about what square roots are, because when I ask a class, and I'll ask you, I want you to shout it out. What's the opposite of squaring something? Okay. The opposite of squaring? Dividing. Opposite of squaring? Squaring. Don't know. Opposite of squaring? Don't know. Dividing. Dividing? Can anybody tell me what the opposite of multiplication is?
Division.
Division. How can the opposite of squaring something then also be what? Division. The only thing is squaring is multiplying by a very specific thing. The opposite of squaring something is finding its square root. Those are opposites of each other. So if you can square something, you should be able to undo squaring it. 2 squared is 4, so the square root of 4 is 2. And it's that concept. You're looking for what 2 numbers multiply together that give you exactly the number that's inside of that square root. That's what you're asking. So, you'll notice when they talk about this and you see a square root symbol, it indicates the principal square root or a positive. sometimes when you get an equation, it's possible that when you're looking for the square root, that square root could be positive or it could be negative. It could have its opposite there. And we're going to talk about that in a minute. When they talk about a cube root, they're talking about what three things would multiply together. Exactly the same things multiply together to give you that number. So, with that being said, working with square roots, it's important that you know, and it's a list, you're not going to find it there. What is 1 squared? 1. What is 2 squared?
4.
3 squared?
9.
4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
49.
8 squared?
64.
9 squared?
81.
10 squared?
100.
11 squared?
121.
12 squared?
144.
13 squared?
139.
14 squared? Anybody?
196.
Whoa, genius.
Did you do it on the calculator? Did you know it? He did it on the calculator? Okay. Listen, it's not that I would expect everybody to know through 15, but you better know through 12. Okay? You just need to know that many. And you need to have them memorized, just like you'd learn how to memorize multiplying certain numbers together. Because finding the square root of something is exactly the opposite of squaring. If I wanted the square root of this column, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Square root of 16 is, and you get the idea, right? Which means that anything that's between 1 and 4 is going to be a decimal. I can't find the square root of 2 or 3 because it's not a perfect square. In fact, it's no longer rational. It's what? Irrational, because it's going to be non-repeating, non-terminating. We're going to talk about how to find those ones that are in between. If you flip to your turn, and the reason I talked about what's the opposite of squaring something, if I want to get this variable by itself, what's happening to the variable? It's being what? It's being squared. What is the opposite of squaring it? Square rooting it. However, when a problem is written this way, I have to remember that it doesn't just produce a positive answer, it produces a positive and a negative. What is the square root of 196? 14. And the reason it works out this way, and please don't get confused by this today when you go to take your mastery test. If I actually put a negative 14 in here and square it, it's going to be a positive when it comes out, because a negative times a negative is going to make a positive. There's a difference between substituting a negative number in here and having something like this, which doesn't have parentheses around it. Everybody understand that that's different. So, a negative 14 squared would give me 196, but also the positive 14 squared would also give me 196. Everybody see that?
So on the test we would put both.
You would put what? That symbol. Or you could write them both out. This symbol means plus or minus. It's just a shorter way of writing it. Okay? When I come over to this one, what's the opposite of squaring? Square rooting. We got to get past squaring being division. The opposite of multiplication is, the opposite of squaring is square rooting. If I square root both sides, it's going to produce a positive and a negative. And people look at this fraction and they think, well, I can't do anything with this. I don't know how to do this. But the nice thing about a square root like this is it really is the same as the square root of 9 over the square root of 256. Okay? What's the square root of 9? 3. And this is outside of the list that we did, but it is 16. So my answer would be plus or minus 3 over 16. It actually, if I split this, it would be 16 times 16. In other words, this is really 16 squared on the inside. And since if I take the square root of x squared and it gives me x, then the square root of 16 squared should give me 16.
How do you get 3 over 16?
What is the square root of 9? 3. What is the square root of 256? 16. So when you see a fraction underneath the square root, you just simply take the square root of the numerator and the square root of the denominator separately. Pretty good? Now, the book puts several examples in here on how to estimate the square root of 3. But they didn't put any your turns in there. So you're going to find this is number 17, like in the guided practice area. You're going to see it there. And here they want me to be able to do this. Notice it said without a what? Without a calculator. And they want it to 2 decimal places. So, the way you estimate a square root is you actually have to know the list. Now, I'm not going to go any further. And what you're looking at is you're looking at this column. Okay? You're looking at the column that's over here. The 1, the 4, and the 9. And what you're trying to do is you're trying to find a number that's on each side of this square root. What is it greater than? What is it less than? Well, 3 is greater than 1, so it's greater than the square root of 1. But it's less than 4, so it's less than the square root of 4. Everybody with me that far? I went to this part of the list, not over here. Went to this part, because this would be the square root side. And I picked a number that was less than and the number that was greater than. Where did it fit in between? Okay? Well, the square root of 1 is 1. And the square root of 4 is 2. So I now know my numbers between 1 and 2. Everybody with me that far? What is 3 closer to? Is it closer to 1? Or is it closer to 4? It's just a little bit closer to 4, isn't it? So, if I think about where the middle is between 1 and 2, the middle would be 1.5. So it's got to be a little more than 1.5. I'm not worried about this. If you can get to 1 decimal place, and by 1 decimal place, I mean if you're on the right side of 1.5, I'm okay. In other words, I don't want you to put down 1.5 here. I don't want you to put down 1.4. 1.6, 1.7, I'm certainly okay with. How can I tell how close this is to what I want it to be? Since I know it's not going to be exact, what could I do? Anybody know? I'd actually do the squaring of it. I could take 1.6 times 1.6. What is 16 squared? We just did it? 256. So 1.6 really isn't there yet, is it? It's going to be maybe 1.7. What is 1.7 times 1.7? Okay, so 2.89 is closer to 3, right? What's 1.8 times 1.8? So now you can see that this 3 is in between these two. And is 3 closer to 2.89, which would be 0.11 away, or is it closer to 3.24? It's closer to 2.89. So you'd kind of pick the middle between 1.7 and 1.7 and 1.8. And you'd go to this side of it. So it might be 1.74. Multiply 1.74 times 1.74. 3.02. That's pretty close, isn't it? So you have to kind of figure out what's the middle. And I'm not worried about 2 decimal places, but I certainly would like you to get within a decimal point, a tenth. It's just a good estimate then of what that number would be. Everybody understand the concept? We good? Okay. Your assignment's going to be 2 through 18 even.